Hey everybody, Dr. Phil here. So this is going to be a video on data analytics and what we term data ecosystems. So let's go ahead and jump right into it. So let's start with an overview of data analytics and data ecosystems. So, what do we mean by those terms? So data analytics, think about analyzing, right? Analyzing data. So we could formally define data analytics as the process of investigating raw data of various types to one, uncover trends and correlations, and number two, to answer specifically created questions. So maybe we want to know something about marketing or about accounting, about finance, whatever it may be. And the process of data analytics really includes the three kind of subcategories of data analytics. The first is descriptive analytics, the second is predictive analytics, and the third is prescriptive analytics. So when we say descriptive analytics, think about describing. So here we're uncovering historical trends in data sets. So it can be thought of as trying to answer the questions, what happened or what is occurring? So like, past tense and present tense. So examples could be, an investigation into ROI, return on investment, or perhaps summaries of past events such as sales, operational efficiency, impact of sales, and marketing. Now, predictive analytics, thinking about predicting into the future, like forecasting, this focuses on understanding, predicting, and planning for future events and business outcomes. We utilize probability analysis techniques as well as data mining, statistical modeling, sort of multivariate statistical modeling, machine learning, and deep learning to generate possible future outcomes given certain conditions. These can be used in a variety of business areas, including e-commerce, healthcare, IT, and cybersecurity. Now, prescriptive analytics, these are used to help determine the best courses of action. So again, this is more prescriptive. These are considered to be the most advanced form of data analytics. So we seek to predict the what, the when, and the why a given scenario might occur. And of course, we can do this for, multiple scenarios. So examples could be tracking fuel prices by airlines to determine possible increases and decreases, monitoring flu strains and activity to determine possible outbreak areas, and analysis of cyber threats and activity to identify possible threats and breaches. So, what are some trends in data analytics? Well, smarter, more scalable AI allows for better learning algorithms, also allows for shorter development times. And of course, in the last, year or so, maybe 2 years, certainly the last year, we've really seen AI kind of come on in leaps and bounds. Composable data and analytics creates a more user-friendly experience, and it makes finding critical insights easier than it's been ever before. It also enables collaboration and insights across, different departments in a firm. Um, Data Fabric as a foundation. So think of like a set of data services that spans on-premise and cloud environments. And we can also think of data analytics as a core business function. We may have not thought about that or thought about data analytics like that in the past, but now we can certainly say it's a core business function. So what about uses of data analytics in business? So we could say improved and effective decision making, certainly improved customer service, increased efficiency of production and operation processes, and improved patient experiences and internal procedures in healthcare. So that's a little bit about data, about AI, sort of how we can use that to help us draw some conclusions on data. What about data ecosystems? So the information technology, IT architecture and infrastructure, software applications, programming languages, and storage technologies used for the collection, storage, analysis, and interpretation of meaningful data. Based on the unique circumstances of each organization, a specialized ecosystem is created for every business entity. So, even two firms that are competitors, like, in the same industry, may have different data ecosystems. So what are the responsibilities of a data analyst? If you got a job as a data analyst, what would your responsibilities be? So a data analyst uses the knowledge or processing software, business strategy, and analytical skill to deliver data and reports that guide management as they create well-informed decision making. Duties can include working on data analytics teams to extract data from large data sets, creating reports that outline key findings, monitoring KPIs to identify success or failure, and analyzing data to identify trends. So what is data-driven decision making? So ideally, this is using data to drive decision making rather than, people's opinions, feelings, etc. So according to Tableau, data-driven decision making is the following. It's the use of facts, metrics, and data to guide strategic business decisions that align with organizational goals, objectives, and initiatives. Organizations are investing in the development of three data-driven competencies. The first is data proficiency. Second is agility in analytics and data analysis. And thirdly, building of a data-driven culture and community. So what is SQL? You may have heard of SQL, or you may have not heard. A lot of people have not heard of structured query language, but they've heard of SQL, and that's all it stands for. So this is a popular programming language used to communicate with databases. It's pronounced SQL or S. So we say SQL, but you really just say SQL. Useful when working with large data sets. It's widely used in today's business environments, and it allows users to filter specific data and to track correlated pieces of data. So how is SQL used for data analytics? So again, SQL, or structured query language, is a computer language, but it's domain-specific language, which means it's used for a specific application. It's used to store, manage, and process data in a relational database management system. It's especially useful in handling structured data. It enables analysts to find relations between data and variables, and it's popular with data analysts and developers because it works well with other programming languages. Now, this is probably a term you've heard before, data visualization. So what is data visualization? So this is the graphical and structured representation of data. Data visualization makes it easier to see the results and conclusions ascertained from data analysis. So think of the old adage, a picture is worth 1,000 words, or a picture is 1,000 words. Now, what if you have too many variables or too much information? And this is where you've got to be careful. So creating data visualizations that include too many variables or contain too much information can distract the audience from the message or information attempting to be conveyed. So for example, if we look at the pie chart, this pie chart represents too many variables and can be challenging to interpret. Now, text that is not legible, unnecessary grid lines, and chart elements can be distracting and deter the effectiveness of the visualization. So if we look over to the right, this pie chart represents the same data, but variables have been consolidated into categories for much more efficient interpretation. This is often a problem, cherry-pick data to, support a certain narrative. So cherry-picking data is the selection and representation of data in a visualization that supports a desired conclusion or result. Data visualizations that include cherry-picked data often ignore or omit data that may contradict the desired conclusion or result. These types of visualizations may mislead and cause false conclusions. So it's important to always be very systematic, very methodical, and very, very objective with the data at hand. So how to structure data visualizations to ensure data is appropriately represented. Data visualizations are tools used to convey a variety of data and information in a meaningful and efficient way. Data visualization is the graphical and structured representation of data, and it makes it easier to see the results and conclusions ascertained from data analysis. When designing data visualizations, there are several best practices that can be applied to ensure effective development and interpretation. Number one, define the purpose. Number two, design visualizations designed for the target audience. Number three, make sure you include all data. Goes back to the cherry picking we were just talking about. Number four, format data visualizations. And number five, where appropriate, use color. You don't want to use too much color, make it distracting. But if color helps, differentiate things, sort of separate things, a color is probably well used. Okay, selecting the right data. Key considerations. So how will the data be collected? Will you use internal data that's being collected by the organization, or will you use data from other sources? And where will you get your data? First-party data is data that's being collected internally by the organization or the firm. Second-party data is data that's being collected directly by another entity and then sold for use, and that's a lot of it. Third-party data is data that's sold by an entity that did not actually collect the data. And what types of data do you need to solve a specific problem? It's important to choose and use data that will help to solve the business or organizational problem under investigation. How much data should be collected? Will a random sample size from existing internal data be sufficient, or do you need a larger sample size in order to achieve statistical significance? And how much time do you have? Time constraints should be identified and data collection should be closely monitored to ensure deadlines are met. And then data transformation. So think of this as the process of converting the format of data from one form to another. Often, data must be transformed to make it easier to analyze. Often, data needs to be transformed so that it increases usability. And data can be transformed by changing format, structure, or value. And now the transformation of data often involves copying or replicating the data, the deletion of database fields or records to ensure data integrity, the standardization of names and variables across datasets, joining of tables or datasets, and possibly converting a file to a different format, such as saving an Excel spreadsheet to what we call CSV format or comma separated values. One thing I'll say about data transformation, this is very popular in the research world. We'll kind of what we call clean the data. If we're working on a research project and we've perhaps collected all the data, we may work on cleaning the data, which means we're looking for missing values and how are we dealing with missing values. And we're generally kind of doing that in a program like Excel before we transfer it into a statistical program like Stata, SAS, R, or POPS SPSS to actually run the statistical analysis. All right, that's it for this video. Thanks as always for watching, and I will see you all in a future video.